Hello and welcome to this lesson about complex numbers. First thing you need to know, there is no real number that you can multiply to itself to be a negative number. So in these situations, we have to create complex numbers of which we will use I. So when you see the square root of negative 1, that's going to be equal to I for this lesson. In fact, I is called the imaginary unit, and it is defined to be I squared. When you multiply it to itself, it is equal to negative 1. Now let's see how it can be used to simplify expressions. All right, you can see on example 1 part A where we have simplify the root of negative 28. The first thing I'm going to do is I'm actually going to rewrite the square root of negative 28 as the square root of negative 1 times 28. Therefore, I can actually square root the negative 1, which will be I. So I times the root of 28. Now, before that you think you're done, you would want to simplify this root as much as possible. 28 is not a perfect square. It's not something I can square root rationally, so I am going to simplify it. I'm going to divide out the largest perfect square that will divide into 28, which is 4. 4 goes into it 7 times. And I'm going to square root the 4, which is 2. So my final answer, 2i times the root of 7. Moving on to part B, and I'm actually running out of paper here, so I'm going to do this at the top right. 6 times the root of negative 45. First thing, since it's the root of a negative, that means I'm going to be using I, just like I did on the previous problem. So take that negative out by using an I. Now, I'm going to simplify the root of 45. Again, not a rational number, so I am going to look for the biggest perfect square that will divide into 45. If you need more help with this, you'll need to go check out my Simplifying Radicals video. Anyways, 9 is the biggest perfect square that will go into 45. It goes into it 5 times. I'm going to go and square root that 9, which is 3, so it's going to be 6i times 3 times the root of 5. The square root of 9 being 3. When it comes out, it does multiply with the coefficient that was already there. 6i times 3 is 18i times the root of 5. All right, there's those two problems finished. Next up, we have simplifying expressions. So if you see something like negative 3i times 4i, you would go ahead and multiply the coefficients. Negative 3 times 4 would be negative 12, and I times I is I squared. As I mentioned at the beginning of this lesson, though, you do need to define I squared to equal negative 1. So to fully simplify it, you would actually substitute negative 1 in place of I squared. Negative 12 times negative 1 would be positive 12. Now, just a heads up, if you have a TI-84 calculator, you can actually type this in, and it will handle the calculation pretty well. The I is on the decimal key if you hit the second key first. All right, moving right into this next one, the square root of negative 20 times the square root of negative 12. First thing, I will represent both of these with an I, so I times the root of 20 times I times the root of 12. Now, if you're sitting there thinking, why didn't he go and multiply them? They'll make it positive. That multiplication property for radicals only works with positive radicands. You can't do it with negative radicands. So you do need to bring the I out first before now you could multiply them. Personally, I'm going to go ahead and multiply 20 by 12 to get to the root of 240. Now, I times I will be I squared as the coefficient. Now I'm going to take 240 and divide it by perfect squares until I find the one that actually works. Did a little work off to the side there, and I got 16. So I times the root, 16 goes into 240 15 times. Now, while 4 also divides into 240, remember you want the largest perfect square that divides into it. This was I squared. My apologies. All right, so I'm going to go ahead and bring this 16 out. The square root of that would be 4. So I have 4i squared times the root of 15. This is almost done. You would want to change the I squared to a negative 1. And 4 times negative 1 will be negative 4. So negative 4 root 15 is my final answer on this problem. On example 3, you can see where we're actually going to throw an equation into the mix. How can we do this? Well, we're going to use what's called square root property, where we're actually going to start by subtracting the 256 from both sides. So 4x squared will equal negative 256. Next up is to divide both sides by 4. The result will be 1x squared equals negative 64 when I divide both sides by 4. Now, to use the square root property, you have to have your variable that's being squared by itself on one side, which I have achieved. Now, I can take the plus or minus square root on both sides. You do need to write plus or minus here. There are two answers to this equation. One will be positive, one will be negative. Now, this is the root of a negative radicand. So I know I'm going to have imaginary answers. So x equals plus or minus I times the root of 64. And I do have a rational value here. The root of 64 is 8. So x equals plus or minus I, 8i, So there are my final answers. And that's representing two answers, 8i or negative 8i. All right, got a useful little note here that we would consider complex numbers to occur in the form a plus bi. You might see a be positive or negative, b could be positive or negative. Now we're going to go ahead and take a look at example 4 where we have two complex numbers being subtracted. Now this works a lot very similarly to subtracting binomials. Combining like terms is how you can think of it, as a matter of fact. Now the 4 minus 8i had nothing to distribute to it. Now I'm going to distribute this negative sign to this binomial. So it's going to be minus 3, and negative times negative 6i is going to be plus 6i. Now I can combine my like terms. In fact, I'm going to be combining the real values. 4 minus 3 is 1. And the imaginary values, negative 8i plus 6i is negative 2i. 1 minus 2i is my final answer. I cannot do anything more for this. And welcome to the last problem, which looks like a monstrosity, but it actually ends up being not too bad. Basically, you have your real parts, which I'm going to be referencing my A, and you've got your imaginary parts, which I'm going to be referencing as B, I. So what happens here is my A value, the real part, has to match. Here, 5x plus 1 is my real value, and 2x minus 2 is representing my real value. Meanwhile, B is being represented by 3 plus 2y and y minus 6 because both of those are being multiplied by I. So the blues have to match and the reds have to match. So A matches A. 5x plus 1 has to be equal to 2x minus 2. And I also have another equation, which is that 3 plus 2y has to equal y minus 6. Now I'll solve both of these, and this is just basic algebra 1 kind of stuff. So subtracting 2x from both sides creates 3x plus 1. I'm sorry I ruined my beautiful rainbow of colors I had going on, equals negative 2. And I'm going to subtract 1, so 3x is equal to negative 3. And I'm going to divide by 3. X equals negative 1 is my value of x. That would make this true. I also need to go find my value of y. I'm going to subtract y from both sides, so it's going to be 3 plus 1y equals negative 6 now on the right. I'm going to subtract the 3. Y equals negative 9 is the value of y that you would need for this. All right, that wraps up the lesson. Please let me know if you got any questions. Thank y'all.